Right. Hi, everybody. Welcome back. Good morning, afternoon, or good evening, as usual. This video will be the start of topic 3.2. And topic 3.2 is called The Origins of Biodiversity. I hope you remember that topic 3.1 was about biodiversity, its definition, and its measurement. And this one, I want to move on to what causes biodiversity, basically, and what it results in. And basically, I want to do that over two videos. This one where we look at the mechanisms, and a second video where we look at the results of, well, as you can see on the screen, evolution pushing biodiversity to occur. As usual, you can see the key terms here. This will form the basis of this video. Basically, there are four mechanisms, and that results in changes to the gene pool and results in biodiversity increasing. I won't go into that yet because it's basically stated explicitly in the syllabus, which we'll take a quick look at. So for this first video, the mechanisms of what causes biodiversity to occur, I want to cover these things. First of all, the statement that biodiversity arises from evolution or evolutionary processes. The starting point for evolutionary change or natural selection, as we'll call it in a second, is variation that implicitly exists within a population. That variation at its basic starting point is genetic variation. We can talk about variation in terms of genotype, or we can also talk variation in terms of phenotype. Phenotype meaning physical characteristics. Here you can see a version of the four mechanisms of evolution that I've already put in my key terms here. Number one, within a population of the same species, there will be genetic diversity and phenotypic diversity, which we call variation. That variation is a starting point which allows some individuals to have better characteristics for the environment they survive in compared to others. I don't like to use, at number three here, they've used the term fitter. It's not a great term. Darwin never used Charles Darwin never used the term survival of the fittest, but it's kind of become ingrained into his work and misused by a lot of people actually. But fitter or better adapted individuals, you might say, have an advantage, which means they'll be selected for survival. You can always look at it more bleakly and say that some individuals are selected for death. The individuals that are more likely to survive are more likely to reproduce. And it says in number four, the offspring of those individuals will carry the genes or the genotypes of their parents. And therefore that gene or those beneficial genes to allow selection for survival and reproduction will be spread throughout the population. This spreading of new genes results in changes in the population, the genotype and the phenotype, that results in increasing biodiversity over time. Maybe it's a good point to state here, life has been on Earth for approximately 3 billion years, possibly longer. And that's an incredibly huge amount of time for this natural selection process to occur. Evolution occurs generally very, very slowly, with a few exceptions where we can see animals or plants with very short reproductive times. We can actually see changes over tens or hundreds of years in some cases. The last two points kind of bridge onto the next video that I want to look at, which will look at the effects of evolution and how that results in, as you can see in the final points, speciation. Speciation is natural selection acting over enough time to allow one species to split into more than one species. And one of the drivers for that is isolation under different conditions. So natural selection is driven in different directions. But that will be the starting point of the next video, will be the idea of speciation or the formation of new species. Okay, I am hopeful that I can cover this in fairly short time, providing I don't waffle as usual. But let's start by looking at somebody I hope you recognise, Charles Darwin, and this is a first edition of his most famous publication, which was called on the origin of species by means of natural selection, first published in 1859. I've read that in 2019, a first edition like this sold at auction for just over $500,000. So it's probably worth just checking your bookshelves to see if you have a first edition of Charles Darwin's book on the origin of species. Possibly likely you don't, to be honest. Okay, so here are Darwin's key observations in his book. And as you can see, it's a slightly potted version of what you can see that the IB has put in the syllabus. So his key observations. 1, variation exists in populations of all species. All living things produce more offspring than actually are able to survive. So he deduced from that there must be some kind of pressure on some individuals surviving and some dying. And he realised that there must be an advantage that allowed those individuals selected for survival to be able to survive and reproduce. In spite of this, population size are roughly consistent. As I said, some characteristics therefore promote survival. And then number 4, although he never understood the idea of genes or genetics, which was a little bit unfortunate because at the same time that Darwin was working, the father of genetics, Gregor Mendel, was doing his work. Basically giving a genetic basis, although he never used the word gene actually, Mendel, giving a genetic basis for what Darwin was talking about, the ability for these characteristics to pass in some way from generation to generation. His conclusion, his observations led him to conclude that that all species evolve over a long period of time, and he came up with the idea of the mechanism that drives that as natural selection. The idea that nature is able to select some individuals due to their characteristics, beneficial characteristics for survival, and others for death. The evidence for this is all around us in the fossil record. And the fossil record, as I've already said, spans 3 billion years of evolution of life on Earth. Okay. Not really on the syllabus statements, but it's just worth stating what is the ultimate starting point for this variation that natural selection acts on. Well, it's mutation. Mutations are, I hope you know, mutations are changes in DNA that are usually actually not beneficial. Changes in an individual's DNA by chance or driven by mutagens, which include radiation, certain chemicals and other things that cause changes, or just by chance cause changes in DNA, usually cause death, often before birth, usually harmful, usually cause abnormalities, but very occasionally might give an animal with those genes and the resulting characteristics, the resulting phenotype, some kind of benefit. Here's an example of a benefit. This is the famous example of the peppered moth. The natural colour of the peppered moth hundreds of years ago was this kind of brown colour. And it's fairly obvious that light brown colour gave it an advantage in terms of selection, because it made it much more difficult for predators to spot on brown tree trunks. Variation still existed, and individuals with black coloration survived within the population, but they were much less likely to survive to reproductive age and pass their genes on. Nevertheless, that variation did exist, and that variation originally came from mutation. Come the Industrial Revolution in England, especially, resulting in pollution, coal pollution especially, and that resulted in the darkening of tree bark in British forests, in English forests. And suddenly that gave, fairly suddenly, that gave an advantage to the dark variation, and it gave the dark variation much more likelihood to survive to reproductive age and therefore pass those dark genes on. And biologists followed that change in the gene pool from basically the genes that gave the light coloration originally dominated, and then after the Industrial Revolution, the genes that gave the black coloration dominated. And that's an example of, first of all, mutation, and secondly, the spreading of these characteristics through a population by means of natural selection. Okay, hope I explained that fairly okay. We can discuss it a bit more in the classroom, obviously. At the risk of repeating myself, here's just another little cartoon version of what I've already said that I found to show you. Members of the same species show variation, as I've already said, in terms of genes, which results in phenotypic variation. In this case, the length of the neck of these animals. Competition exists between individuals of the same species. In this case, in a very simple level, it's competition for food. And again, in this example, the individuals with longer necks will be selected for survival because they're more able to get food resources. So they can outcompete the other individuals with the shorter necks. Number 3, the better adapted, or the fitter, you know I hesitate to use that word, the fitter members of the species more likely to survive, have offspring, and because their genes are passed to their own offspring, their offspring are much more likely to have longer necks than before. Those genes spread throughout the gene pool of that species, and therefore the species over time changes, and we get this increasing idea of biodiversity. Okay, and then finally, just to complete this, an example again in practice. I did mention that there are some species with very short reproductive spans that we can actually see natural selection actually occurring. And possibly the most famous example is, certainly relevant at the moment, is the evolution of superbugs. And the idea that antibiotics especially are becoming less and less able to do their jobs. So here's an example in practice. And consider again the 4 steps in terms of this example. Here we have bacteria. We treat them with antibiotics such as penicillin. Penicillin acts on some individuals that are not penicillin resistant, but there are individual bacteria that are penicillin resistant, so therefore we can see a selection pressure or a selection difference between those individuals with different genotypes. So number 1, variation exists within the population of bacteria. Some are resistant and some aren't. There's competition between them when we add the antibiotics, and the antibiotics select not intentionally obviously, the antibiotics select for survival the bacteria that have this genotype for penicillin resistance. So over time we decrease the genes, or within the gene pool we decrease the occurrence of genes for non-resistance bacteria, and we increase the incidence of genes for penicillin resistance. Selection for survival exists. The resistant bacteria reproduce and they pass on the genes for resistance to the offspring, or to the daughter bacteria, we could say. So therefore what's happening in many countries around the world, especially those countries like Mexico that were not very careful about the use of antibiotics. When I first arrived in this country a few years ago now, antibiotics were available in pharmacies. You could just buy them over the counter, which was a very silly idea then, and it still is in places that still do that. We need to be very careful about how widespread we make the use of antibiotics, because what's happening in many places is that we're producing populations of bacteria that are resistant to antibiotics. Okay, all right, so just before I finish this, just let me go back over these 5 points above my head, because these are the main takeaway points. Number 1, variation exists within individuals of the same species. Some individuals are fitter than others, meaning some individuals are better adapted for survival in their environment. Those individuals that are fitter, in inverted commas, are more likely to survive to reproductive age and therefore reproduce. Their genes are preferentially passed on to their offspring, and because it's those genes that gave them the evolutionary advantage in the first place. And then because of because of those four mechanisms, the gene pool changes over time, and biodiversity increases over time. Okay, I hope that made sense, and we will expand this a bit more in the next video, where I want to look at how these mechanisms result in speciation. Okay, thanks everybody. Take care, and we'll take this further in the classroom.